Thank you, Gautam. And as they say, last but not the least, so I'm Vijay, and this is the most exciting session that you guys will listen to. So let's start with that. Make some noise, please. So I'm Vijay. I actually run this group called Outshift within Cisco. It's an internal incubator within Cisco, and we build products that take Cisco into adjacent markets, new personas, both user and buyer personas. And we incubate throughout the life cycle of the product, so from ideation to building the product, to taking it to market, customer success, and so on. So think of us as a bunch of startups within a big behemoth like Cisco. And I'm here to talk about the Internet of Agents and the need for this, and an ask for all of us to work together to make this open and interoperable. That's the purpose of the talk. So let's dive in. So let's take a step back and think about innovation for a second. So when we think about innovation, we think about innovation in two axes. The x-axis is automation, y-axis is abstraction. So think about work, any work that you do, all of us do. In this case, I'm going with something that is pretty fundamental. Let's say you're trying to build a house, and your building block is literally a piece of brick. So what you would do to build that house is take those pieces of bricks, lay them together, build a wall, build 4 walls, put a roof on top, voila, you have a house. You can automate that stuff. Let's get modern for a bit. Let's say you build a robot that actually lays those bricks out for you, builds those walls, and patches the roof on top. Now you've automated your entire process. So automation makes us more efficient, makes current work better, makes us more productive. That's one axis. But your building block is still the same. It's the piece of brick that you need to lay out one by one. Let's say you wanted to go a level higher and build an abstraction layer, a 3D printed wall. You would build a wall that is 3D printed, and now your abstraction is one level higher. It unlocks new ways of doing things, new ways of doing business. You can also automate that layer. So you can build a robot that takes all of those walls and puts them together into the custom dream house that you guys always wanted. Now, none of us are in this business, so let's get things closer to where we are. What does the tech version look like? So the tech version, same thing, automation, abstraction. We started with hardware infrastructure, and we automated the heck out of it. Not perfect, but we automated the heck out of it. And then we realized, no, it's not going to work out. So we need a new layer of abstraction. We built virtual infrastructure, and that unlocked new ways of doing things. We automated that tier as well. We realized, nope, not perfect. We need another layer of abstraction. We went to cloud-native infrastructure. Again, new ways of doing things. And we've been automating that layer as well. That's not perfect either. So there's something more. And again, it's part of my talk, so I guess you know where I'm going. But that new layer of abstraction is happening right now. But what's different? I mean, yes, are you cranking the wheel again and again? Are you doing the same things again and again? No, this time things are really different. So we have a piece of tech, generative AI, we have a piece of tech, foundation models, that actually are really good at generation. So they generate, they summarize, they transform, and they do this in a very multimodal way. But that's not the exciting part. That's what gets us all excited. But that's not the exciting part. The exciting part is this. These models are beginning to create semantic relationships between the elements of the language. So if you think about spoken language, nouns, verbs, adverbs, adjectives, these models know the semantic relationship between those components, the grammar per se, so that they can predict the next word, the next paragraph, the next sentence. But our languages are not just spoken. Languages are in protein folding. Protein folding has a language. The way molecules combine to build materials, there's a language behind that. So there are languages in science, physics, chemistry, math, all of these things. And so when you have these foundation models start to create semantic relationships, and understand language across all of these different domains, that's when things start getting interesting. Now, beyond that, they are now starting to, like I said, reason. They're starting to plan larger work. They're starting to have long-term memory. So because of all of these things, what we're seeing is the formation of agentic systems. And agentic systems are walking us towards what's known as either object-driven or goal-oriented computing. There are various names, but the basic idea is that you give these systems an end goal, you iterate on the end goal. Once you're happy with that end goal, that agentic system will actually go ahead and solve that problem for you. So it's an ambiguous statement that you give to this agentic system, and then you give it agency to go ahead and solve it for you, invoke the APIs, and invoke everything else that it needs to do to make that happen. That's what's exciting, and what it's doing is adding a new tool in our tool chest. So far, all software has been deterministic. With goal-oriented computing, we are actually moving towards deterministic as well as probabilistic computing, and that's very, very powerful. And if you think about what that market looks like, everything that we built around deterministic systems and software disrupted the way we did software, disrupted the IT stack. That TAM was about 650 billion. Now we are looking at disruption of all work. With agentic systems, we are going to disrupt knowledge work, services work, physical work, because these agents are going to be embodied within robots and solve for physical work. They're also going to change the way we interact socially. So think about where Facebook and Meta is going to take this with agents and virtual avatars. So everything will get disrupted. That TAM is massive. The number here of 4 trillion is the smallest number I could find. There are numbers around 15 trillion plus. There are numbers around percentage of global GDP. I'm not going to go that far, just to say that that TAM is massive. And we are at the cusp of that disruption. So if you think about, again, automation and abstraction, what's forming is this new layer of abstraction, agentic distributed computing, where agents are going to collaborate with each other and solve for any kind of human work or social interaction in the future. And every primitive of work and every social interaction primitive is being abstracted right now. I mean, everything that you see here, that's where we're headed towards. So we need this platform to enable an agentic distributed computation layer to take shape. We've been down this journey in the past. So let's think about what happens. We all know that we invent a new piece of tech, and then we spend a decade perfecting it. So that new piece of tech, in this case, is foundation models and agents and assistants. And right now we're in the phase of building simple agents, simple assistants to solve for specific use cases. That's the scale-up version of what we do. So we're going to take these agents and assistants and build bigger and bigger agents. Over time, we know scale-up doesn't work. So we're already seeing the move towards scale-out, where you take these specific agents and specific foundation models that are good at specific tasks. Think of these as subject matter experts that are really good at certain things, and bringing a whole bunch of subject matter experts together to solve for a problem. That's where we're headed towards with a scale-out vision. So these are multi-agent AI applications that are currently being formed. Cisco is writing a bunch of these, Salesforce is writing a bunch of these, Amazon is writing a bunch of these. All of us are writing a bunch of these scale-up multi-agent applications. But that's not where it's going to end. What's going to happen is you're going to see all of these multi-agent apps come together to solve for a business need. That business need is cross-vendor, it's cross-organization, it's cross-vertical. And that is not going to come, those agents are not going to come from a singular entity. They're going to come from a variety of vendors, and they all need to come together to solve for a business need. Let's make it concrete. So let's take a few examples. We're all IT people, I assume. So let's take a simple example of deploying a software application in your organization. In this case, think about what needs to happen. You need to have a foundation model that takes your business requirements and spits out the service graph of the application that you want to deploy. Once you have that service graph, you need to size it up. You'll need to deploy it. Once you deploy it, you're talking to all of these agents. In this case, it could be ServiceNow agent that talks to a Cisco agent, or that talks to a Microsoft agent, to actually figure out how to deploy this application in your environment. As you deploy it, you'll have agents that do scale checking, that do security checking, that do cost management and observability. So all of these agents need to come together, and I'm really, really simplifying this process. But even in this case, you can see agents from Salesforce, Cisco, Microsoft, ServiceNow, all coming together to solve for a simple problem. Now let's make it more complicated and more real life. They're going to be, like I said, they're going to be agents in science and math. They're going to be agents in social and personal. They're going to be agents that sit within robotic systems. These are embodied agents. Let's say you're a drug manufacturing company. What you need to do is talk to an LLM, go through a planning cycle, provided intent that these are the drugs I'm looking for. As you go through that iteration to figure out, yes, this plan makes sense. Once that plan makes sense, you need to go to a foundation model in the protein folding space, evolutionary science or AlphaFold. So you're talking to agents on this side from a different vendor. That model and that agent will give you a universe of proteins that you can then say, yeah, that looks good, but what's the next step? I need to do testing in a wet lab. I'm not just going to take what the model spits out and take it to production. So I need to go to a wet lab to do this testing. You're talking to embodied agents, robotic arms, that are doing that wet lab testing. Once you've done that, you're going to human trials. There you're going to see reaction testing. You're going to see modification to proteins. There'll be agents to do that. So in this example, you can see you're going across, again, a variety of verticals, variety of vendors, and the complexity, the heterogeneity is just crazy. So how do you bring all of these agents to talk together? So we believe there is a need for an internet scale distributed agentic platform that is solving for that heterogeneity and that complexity across all of these verticals, across all of these vendors and organizational boundaries. So being a networking company, being a security company, being a company that actually invented the internet 40 years ago, we believe that just the way the internet came about in an open, interoperable way to connect monolithic apps, so provide workload to workload and web to workload connectivity, and then you built the cloud internet above that for cloud native apps to come together for service to service and mobile to service connectivity. There is a need to connect AI native apps, agentic apps that are, again, heterogeneous in nature, that allows for agent to agent and agent to human collaboration. And we are calling that the Internet of Agents. And if you're building this new internet for agent to agent and human to agent collaboration, you better make sure that it's secure. And we believe that security needs to be quantum safe, because all of the security protocols that we have today are going to be disrupted the moment you have quantum nodes in play. So when you're building this from the ground up, let's make sure that this communication is quantum safe as well. So that's what we are proposing. And we are proposing that this Internet of Agents, like the original internet, should be open and interoperable. Why open? Because open systems drive maximal value for every entity in that value chain. Whether you're a vendor, whether you're a developer, an operator, or most importantly, a customer, consumer, an open system provides maximum value for all of those. So here's a call of action. If you take one thing away from this talk, it's to point your cameras to that QR code, come together, help us build this in an open and interoperable way. And we're looking for, again, vendors, customers, developers, operators, to come together and provide input and actually build it in the right way possible. And that is the ask here, and that is the call to action. If you cannot get to that, I'm here as well. Ping me, get in touch, talk to me. Let's make this happen. Thank you.